Okay, sir.
Okay, shall we start?
Yes, sir.
Yes.
Yes, sir.
Huh?
Yes, please, sir. Yes, sir, we can start.
Okay.
The recording, you can start.
Now I started the recording. Okay. Today we'll discuss about the two-stroke engines and parameters. Basically, in two-stroke engines, we have see in the two-stroke engines only two strokes. One is upward stroke and another is a downward stroke. And basically, in this, what happens? This is a four-time diagram. I sent already some videos about the two-stroke engine operation and all. You will be knowing it how the two-stroke engine will be working. Okay, this, basically in two-stroke engine, the power stroke, upward stroke and downward stroke. In this, in upward stroke, the fuel will be taking to the basically in a two-stroke petrol engines. What happens is we have a carburetor. Carburetor is a mixing chamber where the fuel and air will be mixed fixed quantity, and that will be entered through the crankcase through the inlet port. Whenever the piston is going up, the inlet port will be opens and fuel will be going up and getting a combustion while in the upward stroke itself. Ending up the upward stroke, the combustion will take place and it comes down to the backwards and pushing it up. Then that is called exhaust stroke will opens. The basically whenever the thing will be happening, it whatever the fuel is a diesel fuel or petrol fuel, total fuel will not be burnt. Partial fuel only will burnt and other will be having the unburnt hydrocarbons and lot of exhaust will be left over. And cleaning of the exhaust is the one process where we can have it to the through the exhaust gases and fresh air will be injected inside the cylinder. That is the major thing. For that only in petrol engines, in two-stroke petrol engines, these problem will be the more because in the four-stroke cycle we have suction, compression, expansion, and exhaust. But in a two-stroke cycle, only two strokes and operations will be the more. Cyclic process is the more and more, and rapid process will be happening. In a four-stroke cycle, two revolution of the crankshaft. In a two-stroke cycle, only one revolution of the crankshaft. That's why what happens. We are going to have this scavenging process in a two-stroke cycle. That's why we have a lot of modifications will be happened in this two-stroke engine process to improve the efficiency of the engine. And scavenging. What is the scavenging? The definition of scavenging is the process of replacing the exhaust gases inside the in a cylinder of an internal combustion engine with the fresh air, fuel mixture, or the fresh air in case of direct injection engines for the next cycle. If the scavenging is incomplete, the remaining exhaust gases can cause the improper combustion of the next cycle, leading to reduce the power output. Basically, what happens in while taking to the inlet, opening of the inlet port, exhaust fresh air will enter into the chamber and combustion will be taking place. Once the combustion is spark is given, combustion is taking place. Because of the combustion, power is getting down. The piston will be getting down because of the power stroke, and the leftover gases to be pushed up to the exhaust gases through the exhaust port. And this will not be happening it, and temperature and things will be happening it. Remaining unburnt fuel particles and the temperatures will lead to getting of the improper combustion in the next cycle. And the fresh air may be admitting it, fresh charge may be entering it, but still the exhaust gases also will causes the problem. That problem will be basically we call it as the scavenging. Scavenging is the process of replacing the exhaust gases inside the cylinder. How to replace the previous cycle's gases from the combustion chamber. That is the main thing here. With this fresh air or the fuel mixture or fresh air in the case of direct injection engines for the next cycle. If scavenging is incomplete, the remaining exhaust gases can cause the improper combustion for the next cycle, leading to the reducing of the power output. That is the major definition of the scavenging. Now we are going to have the scavenging efficiency is the ratio of the trapped fresh air as the total mass trapped in the cylinder. Basically, you know what is scavenging now. Scavenging means whatever the leftover gases to be pushed off to the from the inside the combustion chamber to the exhaust through the exhaust valve or exhaust port. Scavenging efficiency is the ratio of trapped fresh air to the total mass trapped in the cylinder. Other define scavenging efficiency as the ratio of trapped fresh air to the maximum theoretical amount of fresh air that could be retained in the cylinder. Because once if you want to get the combustion, fresh air is required, fresh oxygen is required, oxygen percentage is required. Fresh air will have the oxygen and the charge will be mixing with oxygen and the fresh air with the fuel and the carburetor and coming to the mixture to the inside the cylinder, and that should be having good ratio, good percentage of oxygen, then getting of combustion is very easy. That's why we have to cleaning process of the, after combustion, cleaning process of the remaining gases is very important. That's why what happens, the scavenging efficiency to be improved is the ratio of the trapped fresh charge A total mass trapped inside the cylinder. Other defines scavenging efficiency as the ratio of the trapped fresh air to the maximum theoretical amount of fresh air that could be retained in the cylinder. That is the major thing we have. And this is about the scavenging and scavenging efficiency. And we have the two terms. One is the delivery ratio and trapping efficiency. What is delivery ratio? A delivery ratio is defined as the ratio of the amount of charge retained in the cylinder to the total charge delivered to the engine. It is defined as the ratio of the amount of charge retained in the cylinder for the total charge delivered to the engine. And trapping efficiency indicates that traction of the air or mixture supplied to the cylinder is retained inside the cylinder. Because whatever the charge you are going to, metered quantity of the charge will be centered from the inlet port will be having, always it is having the equal charge, equal amount of quantity, equal quantity of fuel only sent inside the cylinder. But if you have the leftover gases will be there, that leftover gases will have some temperature, then unburnt hydrocarbons and all other fuels that may cause us to getting of the complete combustion. Because anything in petrol engines or diesel engines, complete combustion may not be happening. Initially, in first cycle, complete combustion may be happening, and there also we have some leftover gases that will be carried out every cycle. That is the major problem where we are going to have getting of the scavenging. And basically, we have a trapping efficiency. We already know the definition. It is the ratio of mass of fresh charge retained in the cylinder to the mass of fresh charge supplied. What is the fresh charge supplied and retained charge? It indicates the what fraction of fresh charge supplied is retained in the cylinder. That is the, we call it the trapping efficiency. Trapping efficiency will be defined as
Sir,
MI by tell me.
sir, does charge here means the fuel or the fuel and air mixture?
Yes, because if it is a gasoline engine, we have a fuel and air mixture. Basically, in a two-stroke engine, always we talk about the gasoline engines. Gasoline engine means SI engine, spark ignition engines.
Okay, sir.
But anything, SI engine or CI engine, the same thing will be happening inside a cylinder. Basically, whatever fuel we are going to send it, the complete fuel will not be burned. Because of the unburned fuel burnt and leftover charges will cause us some issues. That's why we will not have 100% efficiency. Always engines will be having more than below 50% of the efficiencies. That is the major problem. That's why efficiencies will be thermal efficiency or mechanical efficiency or brake thermal efficiency. And one is the frictional factor is there. That is also another thing where we have a moving parts. There you have where we have a moving thing. Piston will be always moving from TDC to BDC. We have some frictional losses. Then again, these are the problems will be happening inside the combustion chamber. It also gets the decreasing of the efficiency of the engine. One is MI is the mass of the fresh charge retained per unit time in the cylinder after the ports closes. And MI is the mass flow of fresh charge per unit time supplied to the engine. That will be having the trapping efficiency of the engine. And if you take scavenging process in a different thing, ideal, tell me.
Sir, delivery ratio and trapping ratio are both same now, sir.
Delivery ratio and trapping ratio will be the same.
Trapping efficiency are both are same now, sir.
Both are same only, but one thing is delivery ratio will be calculated through whatever the fuel we are sending inside. Okay, that is one thing is whatever the fuel we are sending through this inlet port, that is the delivery, how much delivery of the fuel we are sending inside the combustion chamber. And the trapping efficiency is the ratio where we are going to that fuel plus whatever the leftover content will be there inside of the cylinder, that will be added to this fresh charge for getting of the combustion. That's why we have a small difference here. I hope you understood.
Yes, sir.
Okay. Next, we are going to have the ideal or theoretical scavenging process. In this, we have a perfect displacement model, a complete mixing model, and source substituting. These are the three different methods we are going to evolve for the to reduce the scavenging losses of energy. And first one is the perfect displacement model. In this perfect displacement model, this model is based on the following assumptions, and the fresh charge would be pushed to the residual gases without mixing it. The model based on the following assumptions, the fresh charge would be pushed the residual gases without mixing it. Thus, there is no mixing of the fresh incoming charge with the burned gases. That is a major assumption we are going to take up for the perfect displacement model. The fresh charge, whatever the, just now you asked, delivery, this thing will be charged, would push to the residual gases without mixing it, and thus this is no mixing of the fresh incoming charge with the burned gases. And second one is there is no exchange of heat between the fresh charge and the burned gases. There is no exchange of heat between the fresh charge and the burned gases. These two will be only assumptions, because once the cycle will start, uh, whatever the percentage of leftover gases, whatever gases we are pushing it out, still we have a remaining, some residues will be there inside the combustion chamber, and some heat also will be there, because immediately we have a one power stroke, immediately next we have another power stroke, because the crank revolution is only once there. In a four-stroke cycle, two revolutions of the crankshaft will be there. That way, in his two-stroke engines, either it's a diesel engines or a petrol engines, gasoline engines in a two-stroke model, these problems will be reoccurrence will happens because of the fast moving of the piston. And there are there are two cases. There are two cases arise in the model, and one is the scavenging ratio is less than or equal to 1. The scavenging ratio is greater than 1. In two cases, where observations, we are going to assuming the pi two things. What happens if you make the two cases? And we have uh, the complete mixing model. If you complete mixing it, what happens? And if you mix the complete mixing model, the fresh charge entering inside the cylinder mixes instantaneously and uniformly with the residual gases. Thus, the complete mixing occurs. The fresh charge entering inside the cylinder mixes instantaneously and uniformly with the residual gases. Thus, complete mixing occurs. Basically, if you say it or not, because whatever the fresh charge will be coming from the inlet port, that will be mixing to the whatever the leftover exhaust gases will be mixing it. The scavenging process is considered to be a quasi steady flow process. You know what is quasi steady flow process? What is the quasi steady flow process? Anybody can tell? Thermodynamics?
The process in which it takes place at a slow rate, and therefore there will be maintenance of equilibrium between the system and the surrounding.
Yes, very good. Actually, if you take a one vessel inside the water, inside we have small particles will be there, and slowly removing one by one without changing of the equilibrium position. Because slowly we are going to mix it, going to without change of the position, we are going to replace one by one or mixing it. That is, the scavenging process is considered to be a quasi-static flow process in this. That's why prerequisite of thermodynamics is required for a study of the IC engines. The density of the incoming charge and bound gases is the same. The density of the incoming charge, because the incoming charge and bound gases is the same. These are also assumptions. If you have a complete conjunction, what happens? The residual gases are at the same temperature and have the same molar mass and fresh mixture. Basically, what happens whenever you are mixing with the fuel and air mixture, we have a lot of molecular mass. Okay, molecular exchange will be taking place, and this thing, fresh air will have a very and fresh air will also will have the more oxygen percentage and all, and whatever the residual gases will be there, that will be having, because already it's having a combustion, but it's not completely burnt it, but unburnt things are there. that again the more temperature is required to burn for this, because the same whatever the spark you are giving to the spark strength and spark voltage, everything will be the same. A two-stroke cycle for gasoline engines for giving of it. But fresh charge can be burned very easily comparing with these residual gases. The piston remains at BDC during the scavenging process, because once the combustion will be happened, the piston will be going down to the bottom dead center. Again, if you pushing it only, it goes up for the relieving of the exhaust gases from the inside the cylinder. And the cylinder pressure is assumed to be constant during the scavenging process. The cylinder pressure, because what happens, the pressure of the cylinder, because you know the stroke length and the stroke diameter also we will knowing it. In this area only we are going to concentrate. This pressure will be, the cylinder pressure is assumed to be constant during the scavenging process. Okay, temperature and pressure will be down to a lot of things in a scavenging process or the combustion process. Then we have a short circuiting. In this model, the fresh mixture might flow through the cylinder and out of the exhaust ports in a separate stream without mixing with the residual gases or without pushing them out. In this model, the fresh mixture might flow through the cylinder and out of the exhaust ports and the separate stream without mixing with the residual gases or without pushing them out. In this case, only a little fresh mixture would be trapped, and the scavenging efficiency at any value of the scavenging ratio would be very low. This is also one of the method model we are going to adapt for improving of the efficiency of a two-stroke model, two-stroke engine. And this is a very important process where you have modifications of the piston crown, and while entering into the inlet port, and a lot of things will be happening. Lot of process will be happening. Lot of modifications will be made for making of these practical scavenging methods. Because previously you have seen the various methods, why the problem will be occurring and all. In this practically how to solve this problem by using the different methods of the different models of the connecting of the supercharger to the engine roots blower, fan, or whatever it may be, to sending of it and cleaning of it and all. Now we'll see the uniflow scavenging method and loop scavenging method and cross flow scavenging method. Particularly in a single cylinder engines, we will see more in cross flow scavenging system, and multi-cylinder engines we can see the uniflow scavenging system or loop scavenging system. And uniflow scavenging system, in this exhaust valve is fitted at the top of the cylinder. Basically, anyhow, inlet valve or exhaust valve or thing will be in a four-stroke cycle. We have the method of having the valves in the top, the head of the cylinder, inlet valve and exhaust valve, and at the lower part of the cylinder, the fresh charge entered the cylinder from the two inlet ports, which pushes the exhaust gases to go out through the exhaust valve. This is anyhow, I will show the figure. The fresh charge enter into the cylinder from the two inlet ports, which pushes the exhaust gases to go through the exhaust valve. The direction of the flow of the fresh charge and exhaust gases is the same. Hence, it is known as the uniflow scavenging system. This is about the uniflow scavenging system. If you have a small modifications in the system, then cylinder cannot have any modifications. So if you have, the engine will be having three blocks. One is the cylinder block, cylinder head, and we have a crankcase. In this, basically, what happens if you want to do any modifications before the crankcase or the cylinder head only. And cylinder block is a rugged one where you can have a piston and the cylinder will be moving up and down. The valve arrangement will be taken care by the cylinder head. That's why we are going to see this here. We have a fuel injector will be there. We have a puppet valve. We have a small puppet valve will be there. Then we have a exhaust outlet will be given on the top, and the scavenging air inlet will be there. Basically, we have a, and scavenging air inlet will be given, and two air inlets will be there to have the flow will be uniformly to close to the air to the top, because this will be in a two-stroke diesel engine, and this here we are seeing it to the uniform flow of the air will be flowing it here, and here we have a fuel injector. Basically, in diesel engines, we are going to have the piston will be moving upwards whenever the inlet valve opens, and charge will be entered inside, the air will be entered inside, and here the volume is reducing and pressure will be increasing. Pressure and temperature will be developed, ending of the compression flow. because the volume is reducing and air will be having a pressure. That time two valves will be closed and all. Ending of the compression stroke, we are going to release the fuel. Fuel will be releasing it. Here we are going to get the combustion. Here we are going to get the combustion, and because of the combustion, the piston will be coming down. That time itself, after combustion, we are going to have the exhaust gases will be pushed over to the outlet, and there we are going to have a small, like a exhaust valve type. We have a puppet valve will be given in this design. This is a small modifications in the head design or uniform flow of the fuel, having the uniform distribution of the air from the inlet manifolds of this. And here is a CA engine model, two-stroke CA engine model of uniform flow. And this one cylinder is shown here. This is the cooling system and all. And here two air inlets will be given. One is the air scavenging inlet, another these air inlets will be given. And before going to go to the piston to the top dead center, takes the air from the two air inlets, and uniformly it carried out to the top and getting up the combustion. After combustion, the puppet valve will opens and the exhaust gases will be pushed over to the air very easily. Okay, this is one model where you have a uniform flow of the scavenging. And we have a loop flow scavenging. In this type, the inlet and exhaust port, in this, the inlet and exhaust port both are situated at the one side of the lower part of the cylinder. And in this, the inlet and exhaust ports, because basically any engine, we have inlet port and exhaust port will be there. It's a wall timing diagram or a port timing diagram. Because where we have the, for reducing of the scavenging, we are going to have two inlets, previous uniform flow, we have shown the two inlets. In this inlet, the inlet and exhaust ports both are situated at the at one side one side in the lower part of the cylinder. The fresh charge flows in the cylinder in the form of a loop and pushes the exhaust gases to go out through the exhaust port. The fresh charge flows in the cylinder through inlet port in the form of a loop and pushes the exhaust gases to go out through the exhaust port. This is another figure I am going to show you. The small changes in the design, and you are going to see this loop. We have a scavenging air inlet will be given, and you have a cylinder is given, and here we are going to have the injector will be there, or the spark plug will be given, and this is about the exhaust. This is a small loop is given. The loop design, we have a circular shape of loop design is given, and in this actually more exhaust will be pushes through this loop, and having more space, it can go to the air very easily. And even scavenging air inlet also, we have a small carburetor will be arranged here. And through this carburetor, we are going to push the carburetor while the piston will be going to the upward stroke and takes the fuel, takes the charge to the top cylinder or the air you are taking it and getting up the combustion. Once the combustion is getting it, automatically the piston will be coming down. While coming the piston itself, and the stroke will be having to the transferring here, power is transferring here, and exhaust gases will be pushed over to this way here in the loop system. This is about the loop model and loop design of the scavenging process. Then we can have a cross flow scavenging system. And this type of scavenging is generally adopted in the two-stroke cycle engine. This type of scavenging is generally adopted in a two-stroke cycle engine. In previous case also we have a two-stroke. Basically, the cross flow we have a single cylinder, but uniform flow and loop we can have a number of cylinders also. More than two cylinders or three cylinders also can adapt it. And basically, this type of scavenging is generally adapted in two-stroke cycle engines. And the transfer port and exhaust ports are situated in front of each other at the lower part of the cylinder. The transfer port and exhaust port are situated in the in front of the each other at the lower part of the cylinder. The fresh charge enters the cylinder through the transfer port and the end is deflected upwards. The fresh charge enters the cylinder through the transfer port and is deflected upwards, because then it comes towards the exhaust port. Thus, it pushes the exhaust gases towards the exhaust port to go. Because additional thing is required to push the exhaust gases to clean the inside cylinder. This is about the crash flow. There also you can see it where you can given one side only. for loops will be given for exhaust and inlet, and here one side is given inlet we are having, another side we have exhaust outlet is given, and this can be using for a single cylinder engines, because where you have a single cylinder engines, most of the two-wheelers, very compact designs are there. That's why what happens, we have a single cylinder engines and fin system also will be there. And in this arrangement of this thing, that's why we have small modifications will come across in a two-stroke cycle. While the crown of the piston will also will be having a small modification. If you see it physically, or you can have a small additional arrangement is made in a in coming classes. I will show you the piston design of a two-stroke engine for modification for reducing of the scavenging losses, scavenging process. So if you see a diesel engine piston where we have a small bowl will be given on the top of the cylinder bowl, and there we are going to get the combustion. Particularly, this scavenging process will be, most of the things will be happening in a two-stroke cycles and two-stroke cycle engines only. And the Russian scientists who have Kendak effect, this is also one this thing. His observations and his things will be there in Kendak effect, that we call it as Kendak effect. It is an effect of pressure waves in the gases, because whenever you are going to send inside the cylinder the charge will have a volume will be slowly reducing, pressure will be increasing it. That we call it a pressure wave or pressure energy. And in simple terms, the movement of the exhaust gas leaving the cylinder of an internal combustion engine creates a pressure drop in the cylinder, which assists the flow of the fresh charge of air or a fuel air mixture into the cylinder. His observations and his suggestions will be telling that we have a small pressure drop will be there inside the cylinder, which assists the flow of fresh air of the air or fuel air mixture into the cylinder. Basically, you have a pressure drop inside, and whatever the exhaust gas is push over it, then pressure drop will help the cylinder or assist the cylinder to taking to the fresh air for getting of the good combustion. That depends upon the fuel air mixture inside the cylinder. This is the Kanadak effect. Now we'll see the small video on the here we have a two-stroke combustion cycle will be there in a two-stroke. Okay, here we are seeing this cross flow, uniflow, and loop flow of the structure of the cylinders. In this, actually, if you see the cross flow, uniflow, and loop flow structure on the top of the cylinder head and the modifications of the flow thing. First, you will see the cross flow of the cylinder, where you are going to have this blue color will have the charge. The charge will be going through this to the crankcase and in a circular manner, and it is going to this and going to enter it here. We have a small design. Basically, what happens in the previous cases, we have a inlet port and exhaust port will be there, but here we are going to have the charge. The charge will be entering from this to the from here to the entire the crankcase, and it is going like this to the cross flow, and where you are going to get the combustion here or the power stroke, then the exhaust gases will be pushed over to this. This is a single cylinder engine where you have a fin system and all. Yes.
Then in cross flow, sir, where the lubricant will be added, sir.
Lubricant also we have separate chambers will be there. Lubricant will be in the center where you have Gaussian pin and crankcase will be there. No, here we are going to have these things. You can see it. I will show you. This. Okay, here we are seeing the picture. No, in this picture we are going to have. This is the another chamber. Okay, this is about the charge. We are going to have this charge. Okay. The charge will be entering here and going to this through this and all. It will not touch the crankcase. This cross flow, these things. Now we can see the loop scavenging. This actually we have two things in the loops. We are seeing it. Two loops will be aiming one side only. Exhaust port and inlet port, or inlet loop or exhaust loop. And where you have the fresh charge will be entering here and getting up the combustion on the top and going to get it to the leaving it. Basically, what happens, whenever you have the combustion, and once the combustion is happened, the complete exhaust gases will be coming down only. And the coming down only. If you have the inlet port at the end, it can goes very easily. This is one method where we are going to see this. This thing basically you are seeing in a four-stroke cycle. Exhaust gases also pushes from VDC to DDC in the exhaust operation. But here in two-stroke we cannot have a separate thing. That's why we are going to have the arrangement. And both places, inlet and exhaust, will be having a separate ports will be arranged here. Piston crowns are not always flat. The piston crown design also will have a small modification. One side will be a little high and have a small cam shape will be there. And that crown will help you to have the easy flow of the easy flow inside the these things. This is about the loop flow. Then you can see this. Okay, you can see this difference between the cross flow and the loop flow, where you are going to have the piston design. The piston is flat here in the cross flow, but okay, here we have a small hump also will be shown it, and this is about the designing of the piston. You can see the piston design. Two-stroke engine piston designs will be having a small crown on this. Suppose if you have a diesel engines, we have a small hole type on the piston top. We have a small hole. Two-stroke diesel engines are never naturally aspirated. They always need a fan or blower for a charging of it. And this is about the this. Now you can see the uniflow process. This is the uniform process. We have seen it the previous picture where you can have the inlet. This will be generally uniform flow of two-stroke engines will be available in the boats, particularly multi-cylinder engines will be available in the boats, because getting up the instant power and more power, we're going to use the two-stroke gasoline engines will be using for a boats, particularly marine engines. Marine engines. Yes. Any doubts? Okay, here we have the uniflow. Previous picture we have seen it. How the air will be entering it and uniformly, and through inlet manifolds, and it will be passing it uniformly. And through uniform operation, we are going to have a exhaust port is on the top, and we have exhaust puppet valve will be there. And through this exhaust puppet valve, and exhaust gases will be pushed over very easily to this. But not really uniform flow will be common flow for multi-cylinder two-stroke engines. And now we have a practical engines also will be available in cross flow and uniform flow. More of the engines will be available, but loop flow engines are very rarely you can see it. This is about the uniform flow of the engines.
Sir, these are all two-stroke diesel engines, no?
Two-stroke diesel and petrol engines. Most of the two-stroke cycle we have more petrol engines only, not diesel engines.
Okay, sir.
A typical important thing is a typical uniform arrangement may not allow charge air into the crankcase. The model shows is only simplified version of the uniform concept. Basically, in this two-stroke engines, in the crankcase only we are going to send the charge to the transfer port to the top. But uniform flow we are arranging on the top of itself. The piston, whenever bottom dead center, near the bottom dead center only, we are going to arrange the exhaust and inlet port will be arranging it, and separate charge will be entering through this carburetor to the engine without the crankcase. Okay, that's why a typical uniform flow arrangement may not allow the charge air into the crankcase. The model shown is only the simplified version of the uniform concept. Now you can see this uniform flow where you are going to have the above the BDC center, we are going to have the exhaust port and inlet port, and through inlet port the uniform flow will be passing of it, and this loop system and all will going to Uniform means top at valve will be there. Any questions? Any answers? Any doubts and clarifications? Hello.
Sir, out of the three scavenging systems, which is the more efficient one?
Uniform flow scavenging will be adapted for the multi-cylinder two-stroke engines, particularly in marine boats and all. But cross flow will be using for a two-stroke engines, modification of the piston crown and all. Loop, most probably racer engines, they are going to use for a loop system, because more space is required for a designing concept.
Sir, which system is used in bikes and vehicles?
Now bikes basically we are using a cross flow only, because the piston crown will be shown at no top, no. Because we cannot change the inlet port and exhaust port, and the system cannot be changed to modifications. Only crown will be having a small change. In this, actually, what happens? So one side will be little more height, and other side will be lower on the piston crown. And if you see practically, go to any mechanic shop and see the piston, there the crown shape will be different in a two-stroke cycle engines, and comparing with the four-stroke cycle engines. But for four-stroke, we are going to have a small bowl type. There we are going to get the combustion. But generally, we don't have a fuel injector mode. Scavenging process will be, gasoline engine is a spark plug method only. We're going to get more scavenging losses.
Sir, how do we prevent the mixing of like the fuel and the air mixture, that exhaust gases? Because it is said like the inlet will be there and it will like move out the remaining gases, but there will be a mixing, na, sir. So how do we prevent it?
That the preventing purpose only, we are going to use different models and different methods and different testings are going on. Basically, what happens, in a four-stroke cycle, we have more time, suction, compression, expansion, and adjust. But in two-stroke cycle, only upward stroke and downward stroke, and a movement of the crankshaft is also, for every revolution, one revolution will be there, in a ports. That's why what happens, power will be the more in a two-stroke cycle comparing with the four-stroke cycle. That's why what happens, we have a less space also for a design concept also, because most of the two-stroke engines will be using for a two-wheelers and all, where the design constraint will be there for location of the engine and all. And most of the engines will be a fin system and all small engines and small power engines and all. That's why compactness will be there. There you cannot have more valves and all designs, and you can have the piston crown design and carburetor. Now carburetor mode has gone, multi-point fueling system has come, because in the carburetor mode, every time the same quantity of fuel will be mixing and sending to the combustion chamber. But in a multi-point fueling system, what we have is whatever the quantity, whatever the speed you are going, whatever the power is required, depends upon it. We have a micro power control based unit will be there. That depends upon the demand of the power, demand of the heat, and fuel is supplying. That's there. It will be reducing the scavenging process and scavenging losses also. For MPFI, DTSI engines, for seeing CRD engines, a lot of models has come up now. Two-stroke engines also, and four-stroke engines also. We have these are the systems depends upon to reducing of the scavenging losses.
Hello, sir.
Yeah, tell me.
Sir, in two-stroke engine, for every cycle, power is being generated, no, sir?
Yes, yes.
But in that case, why are people generally preferring four-stroke engines nowadays?
Basically, mileage.
Okay.
That's the only concept here. Nothing other things are there. But still, race cars, race bikes, and race boats and all, they are using only two-stroke engines. Two-stroke
Okay, sir.
engine will get an instant power, but four-stroke engine slowly pickup will be getting it. Diesel engines. And now we have a multi-point filling system and CRD engines and all. These are giving good economy mode for the motorcycles also, two-wheelers also, but in a four-stroke cycle model. For two-stroke also, it has come up now. Okay.
Hello, sir.
Hello, sir.
Come.
Sir, like what is a crankcase like you were saying?
Crankcase will be having the Gordian pin and crankcase will having the rotation. The crankcase only can be connected to your back wheel of an engine. Crankcase means whenever the power is developing, if you take a four-stroke cycle, suction, compression, expansion, only power stroke, only piston will be moving down forcibly to the crankshaft. The crankshaft will be rotated one cycle. Then the crankshaft only connected with a chain system to your back wheel to moving it. Remaining other strokes are the ideal strokes only. That's why inlet stroke and exhaust stroke or suction stroke, and this thing exhaust stroke, and these are all two strokes: suction stroke, compression stroke, and expansion stroke and exhaust stroke. In this only expansion stroke only you are going to get the but remaining other ideal strokes. But whatever the power is developing in a power stroke, that is a high power, because few percentage of the power will be transferred to your back wheel, and few percent of the power is supplied to your flywheel. Flywheel will stores the energy, and flywheel will be utilized for the remaining other ideal stores. That's why initially, if you want to start the engine, you are going to use the power with the kick rod, or you are going to use with the battery. Initially, you are going to rotate the crankshaft for suction purpose. So you are giving the kick rod or the battery, you are using it for getting of one cyclic process. Once the cycle will be happens, automatically power is generated. The power is stored in a flywheel by using of inlet and ending of the compression and exhaust strokes. But only power stroke power is generated. That's why flywheel is very essential for a two-stroke engine or a four-stroke engine, any engine, for restoring of the energy. Flywheel will play a vital role of getting up the cyclic process.
Okay. Will all
Hello, sir.
strokes have the same speed, or all strokes will have more speed?
One by one. Okay. Hello.
Sir, will
Hello,
all
sir.
strokes?
Say again. Sai, tell me. Amarnath. Amarnath.
Yes, sir. Sir, I wanted to ask. Nowadays, like they're writing on the like specification of engines, like they're using fuel injection system in petrol engines.
Yes, yes. Fueling system is available in the petrol engines.
Then, like how that mechanism is working, like fuel injection. Like suppose like we need to mix our charge in outside, then take it in the cylinder for combustion.
Basically, what happens? This is a microcontrolled based unit actually, microprocessor control unit, and where are electronic unit. Basically, what happens? Whenever the engine requirement, how much speed you are going, how much load you are taking it, and how you are giving the acceleration depends upon the acceleration power. Depends upon the power acceleration, how acceleration you are giving, power will be developed, and how much load you are taking it. And the initially load of your vehicle and the load of your persons who was going, and depends upon this how the engine requirement. From the requirement only, fuel will be injected inside the combustion chamber. That is called multi-point fueling system. Basically, how much power and how much load that basically takes it, and how we are giving the acceleration depends upon the acceleration. Automatically, fuel will be released and combustion will be taking place. Power is developed in a multi-point fueling system. And you are asking about external multi-point fueling system. Huh?
Yes, sir.
External also you can have it, but two-wheelers concept it may not be possible, but four-wheelers concept you can have it.
So nowadays, like vehicles are having different modes, like sports modes or economy mode. So multi-point fuel injection system work on that only.
No, multi-point system will work on that only.
Okay.
Okay, friends, we'll leave the meeting.
Thank you, sir.
Okay.
Thank you, sir.
Okay.
Thank you, sir.